Hey everybody, welcome to our video on Multilink PPP. Today we're going to be talking about MLPPP, its configuration and verification, and we might also go a little bit into authentication. What is Multilink PPP? It's a way to take multiple serial links and aggregate them together under one logical interface. That's essentially all it is. And what you're going to do is load balance across those two serial interfaces. So during this lesson, we're going to create a logical interface called a multilink interface. We're going to aggregate the serial links within that logical interface, that is the physical serial links. We're going to configure these interfaces with /31 addresses, and we're going to verify proper configuration and membership of the physical links within the logical interface. What is the purpose? To aggregate multiple serial links, so sometimes it can be cheaper to bundle several T1s instead of paying for a T3 or whatever the next higher bandwidth you need is. All the links within the multilink have the same IP address and can use a /31 address space. When I say that, what I mean is the physical links get bundled underneath the logical link, the multilink, and the multilink is the only one that has an IP address. So you can take 3 different physical links and put them all under one IP. And what's more, you can use a /31 address space, which is really cool because ordinarily you would be stepping on the toes of the network address and the broadcast address. But since this is point-to-point, it doesn't really matter. The other cool thing that it does is per-packet load balancing through something called fragmentation. And fragmentation is where you take a frame that comes in on the outgoing interface and you basically cut it up into a bunch of little frames, and then it adds either a 4-byte or a 2-byte header to that for sequencing, and then sends it across all of the links, the physical links, within the logical interface, right? So if you had 3 serial links, you could possibly take your frame, cut it up into 3 pieces, put a sequence number on the front of it, and then send it down the pipe. When it gets to the other side, it looks at that sequence number, and that's what tells it what order they go in. The fragmentation, however, is not mandatory. There are other ways that you can configure it. You don't even have to fragment at all if you don't want to. But fragmentation is one of the load balancing benefits of a PPP multilink. Alright, so let's talk a little bit about the configuration. First thing that we're going to do is configure a username and password. This is going to be used later during our CHAP authentication phase for PPP. So we're going to say username Jacob, password Rumpelstiltskin. Then we're going to create the interface multilink. It's going to be number 14. I like to use easy to remember numbers. It's going between router 1 and router 4, so multilink 14. And then we're going to tell it that it's using PPP encapsulation. Then we're going to tell it that it's a multilink, and we're going to tell it the name of its multilink group number. Think of the group number like the bundle or like the bucket that you're going to put all the serial interfaces in. The next thing we're going to do is we're going to add an IP address. Remember how I said earlier we're going to kind of step on the toes of the network address here with a /31 like this. 0.0 is technically its network address, but since it's a point-to-point link and PPP negotiates its IP address, we're going to go ahead and use the network address. So now we're going to go into configuring the serial interface. The first thing we're going to do is tell it no IP address, just to clear out anything that it might have in there. And then we're going to do basically the same thing that we did with the multilink. we're going to do encapsulation PPP, PPP Multilink, and then we're going to give it its group number. When we give it its group number, that's telling it you are to add yourself to the Multilink bundle. Now, authentication with Multilink is always put on the physical interface. So we're still in the serial interface here, and we're going to tell it authentication chap. The host name is going to be Wilhelm, and the password is going to be Rumpelstiltskin. Something to remember about chap authentication: the password Rumpelstiltskin is a shared secret. So the password has to be the same on one side as it is on the other. You can't mix and match your passwords by pointing it to different host names. One thing to keep in mind while we do this configuration is that the interface multilink on both router 1 and router 2 has to be the same, as well as the group number on all our interfaces, both serial and logical. Alright, so I thought I'd show you guys the output of debug PPP negotiation. Up at the top here you can see phases establishing, so it's starting to set up the PPP. And so it goes into LCP, right, which is the Link Control Protocol, and it starts its negotiation. Here you can see it's talking about the MRRU. I'll be honest with you, I do not remember what that stands for, but I remember it has something to do with the size of the fragmentation that they were going to do. Let's see here, it's in LCP for some time, and then it's going to go over into CHAP. So router 1 here is sending an outgoing challenge, so from Wilhelm, and let's see, CHAP challenge, and sometimes it'll do this where it sends out multiple challenges at the same time, and then it has an incoming challenge, right, because we set up CHAP on both sides, so they're both going to counter authenticate one another. So then it's got an incoming response and it's got an outgoing response. Phases authenticating, phases forwarding, success. There we go, that's what we want to see. Outgoing success and incoming success. Okay, so now I thought this was pretty cool. Phases virtualized. So that's talking once again about the Multilink PPP, right? Because the serial link is not going to be a standalone. It falls under something else. Let's see here. Chat incoming success. Alrighty, so this is the Multilink talking now. In case you guys can't see my cursor. Okay, then CDP control protocol, and then IP control protocol, where they're going to negotiate each other's IP addresses. Remember, we talked about that before. So router 1 is saying he intends to use 14.0.0.0. And then I thought this was pretty interesting. I'd never seen this before. The author, and it says her address is 14.0.0.1 and we want 0000, and then it rejects it and it says it's going to use this and then done. And initially what I thought that meant was it was not going to accept the 14 address and it was going to call it by whatever name it wanted to call it, which was 0000. But then you see here it goes ahead and says address 14001, and when it finally gets open, it installs the route to 14001. So that's something I'm going to have to look into myself. But I would like to thank everybody for taking the time to watch this video. I hope it was informative, and I hope it helps you in your studies. Until next time.